anymore. Okay, first let's go over our known values. Why is when the hotel attendant fell on the car? The car is a model Audi Q3, so we know that the height that he ends up at is 1.6 meters. The original Y value we don't really know because the height was indiscernible of the building, and we don't need it in the future. So the original Y velocity would be 0. He doesn't jump off vertically. Vy we have to find. Acceleration is gravity, as it is a free fall equation. And the film is filmed 24 frames per second, and we measured that the falling scene is 37 frames. So multiplying that out, we get 1.54 seconds. Alright, that's our known values. Now we can calculate the final velocity. We can use the third cinematic equation, v equals v naught plus at, plug in the known values that we just went over. So 0 minus 9.81 times 1.54. Velocity is negative 15.1 meters without air resistance. But gravity isn't the only thing that's pulling on this, that's acting on the hotel attendant. There are two forces in total. First one, well, gravity, Fg on Ha. There's the second one, air resistance, FAR on HA. It's not as big as gravity, but it is not negligible. But let's find the force of gravity on the hotel attendant, which we can use Fg equals mg for. The mass of an average Japanese adult male is around 62.5 kilograms. So we can use that to find an approximate force. And multiplying that by gravity, we get a force of 613.1 newtons. And now for air resistance. Now the formula for air resistance is a little bit different. The force of air resistance equals 1/2 of the air density times velocity squared times the drag coefficient times the body surface area. So the density of air at room temperature and at ground level in Japan is 1.204, and we plug in the velocity. The drag coefficient of a horizontal person is 1 when falling, and the average Japanese adult male body surface area is 1.9 meters squared. So putting that all together and multiplying it out, we would get a force of air resistance equal to 260.8 newtons. But now we don't want to find a specific force. We want to find the net force. So we would take both air resistance and gravity and add them up to get the net force. Adding them up would be 260.8 newtons plus minus 613.1 newtons, and we would get 352.3 newtons negative. So that would be our F net. But now we want to find the actual acceleration when including air resistance. So we use F net equals ma, put in the net force we just found. The mass of the man did not change. So we get an acceleration of negative 5.64 meters per second squared. Use the third kinematic equation again to find the velocity, the final velocity when accounting for air resistance. We plug in the acceleration we got times the time, so we get negative 8.69 meters per second. Now we want to find the force of the hotel attendant hitting the car. So change in momentum equals to change in time times the net force. Now we know that the change in momentum is also final momentum minus initial momentum, which is mv minus mv naught. And we know that the crash took 3 frames. So we know m times v minus v naught, the mass doesn't change, 62.5, and 0 minus negative 88.69 should be the change of velocity. Convert the 3 frames into 1/8 of a second because it's framed 24 frames per second. and we put everything on one side. So F net should be equal to 62.5 times 8.69 times 8. And multiplying that out, we get a force of 4,343.
So, what does this 4,343 newtons of force mean? Could it kill this man, or would he live? According to a study by a university in Alaska, a 75-kilogram man can be killed by a mere 3,000 newtons, and maybe even less depending on a situation. Our 4,343 newtons is far more than those 3,000 newtons, and our man is most likely much lighter than 75 kilograms. Thus, we can conclude that this man would have died on impact because his surface area when he hit the cart was also very large, in which portions of his head were hit as well. In other words, that video actually surprisingly summed it up pretty well. All jokes aside though, this man should have died, but in the movie, it showed that he survived. Therefore, we can deem the physics in the movie Bullet Train inaccurate.